So Jock actually provided an excellent platform for my talk. As you can see, I presented the same presentation yesterday at a different conference, which makes me wonder from Jock's presentation if I'm becoming repetitive. Should my presentations be replaced by AI? So who here thinks that should happen? That AI will replace us, it will take over, it will become our landlords, our dominant. Only one person, can't be. Who thinks differently? So actually, that's what I want to talk about. That's why I have the title Progeny or Friendship. Progeny meaning they're becoming a version of us that takes us over, or friendship, they're becoming a partnership with us. And what I want to do is actually lay down some responsibilities and some questions from business to you guys as a research opportunity. And if we're starting with business, I actually want to talk about, so what is AI really about? How do we as business understand it? And I can say that now that I've only been in business a few months and in research many, many years. And then I want to talk about this AI-human connection. Are they really going to take us over? And how do we partner with AI? I'm going to talk about what's the research to do? What do we want from you guys as a business community? And then ultimately, some success stories. For business, when it comes to AI, this is what it is about. The first thing we want is decision-making in real time. That is why it's a hype now. That is why data science, analytics is all a big deal in industry. Industry and businesses has become so complex, consisting of so many different parts, that one CEO, one board can't make decisions so quickly. We want to make it in real time, and we need you guys as AI specialists to create the tools and the AI algorithms for us to help do that responsibly. Secondly, we want to optimize our internal operations. And again, if you have a business that spans the globe, consists of thousands of people, Deloitte has 230,000 people, it spans the globe, it's in every economy. How do you manage a business like that? How do you optimize it so that it is efficient and cost effective? Only AI can do that. Only AI can troll through that data and actually come up with an answer for that business question. The last thing that business want to do is come up with new products. And that's what we mean with insight-driven innovation. AI helps us understand customers, help us understand our products, and can come up with new products. That's why in cancer research, they're using AI. There's no human being that can go through all the different chemicals and all the different human genomes and come up with an answer for this particular cancer medicine would work for that person. Because that's what they do in cancer research, right? Only AI can do that. And ultimately, this is the three things that business wants us. And this is what we want to anchor in for now. And why do business want this? Because business and institutions has become data-driven organizations. Anywhere you go, you'll see a telecoms company saying, no, we want to become a tech company. We want to be digital. You'll see a retail company saying, no, we're a digital company. Because they believe they want to become data-driven organizations. And the reason for that is the fact that technology is changing. You guys know it. You guys know, if you started your PhD 6 months ago, you're already behind if you didn't do your literature survey properly, right? Because there's already somebody who presented this morning something, oh man, I didn't think of that. And he presented it this morning. Technology is changing quickly. More importantly is that society is changing. I always tell people the story that my younger brother has a 1-year-old daughter, and she knows me via WhatsApp call. When I physically visit her, which happens rarely because they're in Cape Town and I'm in Pretoria, she's like, oh, weird, she doesn't recognize me. But when she sees me on a WhatsApp call, it's like a different story. People are interfacing with technology in a different way, and therefore they are asking businesses to interface with them differently, and they're asking the research community to do different things. And then ultimately, the business models are changing, right? Uber, Airbnb has shown that you don't need to own assets to run a business, right? It's different from the way before. Production is different. Business models is different. Services are different. So businesses need to know that actually when we integrate all three of these things, we are digitalizing ourselves. We're running a different business, we're interfacing with our customers differently, and we're using technology in a different way. What does that therefore mean for the AI community? What that means is that, as Jock had said, there's three things, right? There's assisted, we all know that. It's sort of, here's my data, run some AI algorithm, this is my business problem, give me an answer. That's the stage where we're at now. But there's responsibility for us as data scientists because we need to know if we give them the answer and we know we're never sure, it's probably only like a 75%, 80% if you're lucky probability or accuracy rate. But we need to be responsible and tell them, you cannot stake your claim on this. Either the data was dirty or problematic, or we know our algorithm isn't 100% back. But the 80% is still good enough. So the human being still makes the decision. That's assisted technology. You've given me more information. I know it's not completely accurate or perfect, but it's good enough for me. I can make a decision. The second one is sort of what we call augmented intelligence. And that is sort of where there's a layer of AI between me and the data, and that AI is already making some decisions, but I still press the red button. I still do the main important thing, right? And there's a responsibility for that person that creates that AI layer and that AI algorithm, because they must make sure if the AI says this way, that there's some ethical story around it, it adheres to the regulations, it's fine. I can trust that if the AI says X equals 1, I can press my red button. The last one is the autonomous. Here the AI is making the decision itself. It's already happening. Trillions of dollars is being traded globally by AI algorithms. We don't know it. We think there's somebody that sits with my pension funds and makes a decision. No. An AI algorithm is making trillions of dollars of trades every day, every second. Is it ethical? Is it moral? Who created that AI algorithm? Who owns the decision if there's a mistake, if there's suddenly, somebody didn't calculate for that particular instance in the algorithm, the AI made $1 trillion deal and that money is lost in your pension fund. Are you going to blame the guy who created the AI algorithm? Are you going to blame the guy who implemented it? Who are you going to blame? And these are the questions when we're in the third section we have to start asking. The ethics and the morals and the ownership around what AI does. Because ultimately, it is around insight. What business wants is they want to understand what happened in the past, and they want to have a better idea of what to do in the future. We can think that AI should do that for us, but ultimately the human is involved. And we know this, right? The human gives you some model of the world, and very often we as AI researchers skip that. We just said, I don't care, just give me the data, I'll learn the model. I'll learn what the model is, and I'll give you the answer. But actually, if we can get from the expert, from the human, some knowledge of the world, incorporate it into our model, let the human do some parameter tuning, show it to the human, show that mapping, that visualization, then we'll actually come up with a better model. Then we'll actually come up with a better algorithm. If we take the knowledge of the world out of it, and we take the human out of it, which we do most often, we come up with a good solution. But then there's a lot of problems in terms of how accurate is it? Does it really model the world of the human? It doesn't need to model the whole world, as we heard this morning. It can only model the world of the human, and that already would be good enough. That already would be perfect. Because, as I explained before, in businesses, this was the paradigm. You have some guy working on the data, he comes up with a report, sends it to his mid-level manager, that manager sends it to his senior manager, that senior manager sends it to the executive, that executive creates their own report, which looks differently from the one the analyst created, presents it to the board, and then the board makes a decision. That's a 6 to 12-month journey. Meanwhile, the world has changed. Meanwhile, Google has created something different and has taken over already a part of your business. We want data collected from everything, meetings included, meaning unstructured data, and everything else, IoT, structured data. And we want to make sure that that business implements decisions. That's the most difficult thing as a data science, convincing somebody else that your algorithm came up with a good answer and they must implement according to that. Unfortunately, as human beings, still believe in our own wisdom and in our own interactions. But then the question becomes, who implements this in this new world? If the AI implements it, are there problems with it? Or must I, as a human being with AI, do that? Because ultimately, we want this partnership between humans and AI. Humans have some good things. And if you look at the sort of 4 factors shown here, we're slow at computational ability. We want to use calculators. We want to use Excel. That's where computers beat us. They're faster. They're more accurate when it comes to computations. In the second factor, we, as a random number generator, are great. That's why we're creative, right? We look at all options. We can make, if I ask you guys, come up with a number, it will be anything from 1 to 1 trillion, because I spoke about 1 trillion earlier in my speech. A computer has that normal distribution. It will stick here into a small, narrow range. And that's sort of where we are great at creativity. And then we have this common sense. We have amongst us this folk knowledge that we've collected over thousands of years of human beings. And that common sense helps us make decisions at a different level than a computer would do. A computer, even if it took and modeled all the information on the internet, will still not be able to do and make a great decision based on uncertainty. We do that. We use that sort of common sense, that connection that we have. And the fourth thing in which we differ is in rationality. If I have a mother and I put that mother in front of a path and I tell her path 1 has 100% certainty that you'll die, but your child is there. Path 2, your child isn't there, your child will die, but you'll be safe. That mother would always choose the path, even if it has 100% certainty of death. A computer won't. It chooses the optimized percentage, right? It doesn't have that ability to think beyond rationality that human beings have. And therefore, in terms of AI world, this is what we do. We focus on optimization, we create optimization algorithms because we want to look through the data and find the minimum point. We do connections. This is what machine learning does. We say, here's the input, here's the output. Create multiple weights and connections between multiple layers so that this input or new input will give us a similar output. We then say, okay, let's then prescribe. We create generative algorithms. We create simulations. We say, okay, in these different simulations, that one is the best. So we prescribe to our humans what to do. And we create models. We create statistical models and say, given this data, this is the model in the data. And ultimately, this is what we can do from an AI community. But how do we put this all together? How do we make sure that in the future, AI and humans can actually work as a partnership, as a friendship? Ultimately, you take out the middle part, right? And then you say, actually, you know, machines can learn from humans. That's where deep learning networks came from. We saw how the brain worked. Machines can learn from humans. We can model and codify expert knowledge, and that can be an initial parameters for our model, for our algorithm. And then machines can provide benefit as well, because we as humans can do that. When AlphaGo beat the Go champion, what happened? The Go community went and looked at the games. Hey, here's some new moves. Here's some new structures that we didn't know of, that we didn't think was good, that in our 1,000 years of practicing Go, we couldn't figure out, but this machine figured it out for us. So we as humans are learning from machines as well. We are ultimately learning from each other. That is what was great about Web 2.0, about the social networking, where we can share information, we can learn from it. Our common sense, our folk knowledge as a global human community increased. And that helped us learn the machine more. And machines are learning from each other as well. You know, Facebook created these two machines that was talking to each other, and ultimately they created a new language. They were learning from each other. That's the whole concept about reinforcement learning. It's essentially two machines that's playing against each other and learning from each other and becoming better. And if we put this all together and we say, but actually we can use AI's consistency and accuracy with human creativity and ability to think complex, then we can come up with new innovations. Then we're doing something better. I don't know how many saw that Kasparov article where they had this chess tournament where you could do anything. You can have AI just playing AI machines, whatever machine you wanted to use, even if you wanted to use the AlphaGo chess, whatever. And they actually found that AI plus we humans plus a good process beat everybody. So yes, AI beat the grandmasters. The AI machines were better. But if you add a human there and you add a good process of how they actually should work together, who's responsible for what? Who does this action? So the human being is responsible for this part. I give it over to the machine is responsible for that part. He gives it over to me, and we've got a good process going. That is better than an AI by itself, even the best chess machine that was out there. Because ultimately, AI is there to help us. It's there to help us understand the world better and make sure that together we create a different world. But you see, this is how we see it. We see it as this version of ourselves. So I don't know who saw the Alien franchise. This was sort of an AI machine that was created, Android. It was basically a version of the guy that was standing there. And what did he do? He asked it to play some music for him. And when the Android asked him, which should I play, he said, you choose. So you created this ultimate machine, and then all you ask for it to do to function like an iPod shuffle, which is actually kind of stupid. Or we see it as something that wants to cheat us, that wants to become better than us, that wants to beat us, which for anyone who watched Ex Machina is essentially what this did, right? This android that manipulated this being, by being sexy and attractive, manipulated this man into freeing her, right? I shouldn't give the story away, sorry. Or we see it as this force that's going to take over, this force we can't trust, right? That's going to take over from us. So now we get to the researchers, and I want to challenge you guys, because I want to say, you know, there's about 4 different things, and I know this is a deep learning conference, but there's about 4 different things in AI. We do a lot of what we call knowledge representation in ontologies, right? This is the semantic way. This is the philosophical way of doing AI, not the sort of statistical way in which we do deep learning. These are the guys that sit with their math and work out formulas. And they are almost too formal to be practical, right? Ontologies has been around for years, and still somebody hasn't figured out a way to make it valuable for business. Yes, there are things like SnowMet and all of those kind of things, but it's almost too formal to be practical. Then deep learning came around, and business was, whoa, yay, sexiest thing since sliced bread. But it was almost too practical to be understood formally, right? We still don't understand. We still see it as a black box. Why is it working? So when you go and present and you say this algorithm gives an 80% accurate, the guy's like, how, why? The CEO asks you, how did you get there? And we don't know. We just say, well, we ran the data and it came up with this thing. So that is why some of the research that's going on now is trying to understand deep learning and trying to understand these deep networks. You saw the keynote this morning. Then we have statistics, and statistics is almost too realistic to be precise, right? It sort of gives you a view of, I think the model of the data is somewhere in here. 60% of the people are this tall, and then you have outliers, right? It's not too precise, but it's good. You can use it. It helps you understand trends. And then ultimately, if you look at mathematical modeling, it's so precise that it can't really be realistic. It's like, yes, this is a specific formula of how the galaxy works, but it can't, you know, quite understand why that black hole appeared there, even though we could now currently with our mathematical modeling, but it's not perfect. So where does this leave us? So now what? What are we to do as an AI community? Number one, let's learn from our successes. I love this example. It's in everything of my presentation. I should make a video of myself and turn the text to speech and let an engine speak it. But this is fast innovation, right? This is people that's collecting data from the till slips, from their cameras. Is the lady looking at the black dress or the red dress that's training their people that's in that shop to look at and put the data onto their mobile devices. That data goes immediately to the headquarters in Spain, where the designers are sitting. Their designers are looking at this data, interpreting it, have some AI algorithm that helps them interpret it, and then they come with new fashions, and within 2 weeks, that fashion is in the shop, everywhere in the world. Right? That is fast innovation. That is AI making fast and accurate computations, human beings creating new products, and the two working together to create innovation. Amancio Ortega came from nowhere to be the 6th richest person in the world in 10 years because they use AI in the correct way. So learn from our successes, but also learn from our mistakes. Right? We all know about Google that had this problem with the gorilla images. We all know about Facebook that created this 2 AI engines talking to each other. So what does Google do? They say, let's just remove this. Why not study why it went wrong? Why not study why it overfitted to that particular data? Why not change the algorithm? But they just remove the images. So why don't we should actually learn from our mistakes? How did these two start talking to each other? They started talking to each other because instead of us, like we speaking, turn that light off, it was better just to send the one, and the other machine would understand one means turn the light off. So they just came up with a quicker way of communicating with each other, because between AI algorithms, all they want is optimize time and optimize the output. And they did that. And let's understand, instead of turning it off, which Facebook did. Let's understand what happened there and how we can actually use it. Then we must learn from future requirements. And in the future, we would have this sort of augmented reality where a factory worker would have a haptic glove and a helmet with a sensor and some bodysuit. And all the information that comes from our IoT sensors will be fed into the machine with the machine interfaces with the human. The human would make a decision, and just as the human makes a decision, this robotic arm makes a decision as well, and the two works together. Or on the right-hand side, where we have customer experience, where Delta Airlines are now putting gesture recognition checking. You just walk up, it sees you, it checks in you immediately. This is a different customer experience. So how do we use AI to actually incorporate this? This is the future requirements. The future society will ask this. And are you currently doing research that's enabling these kind of things? And then let's learn from nature. We're good at this. We saw how the brain works, we created neural networks, and then we created deep learning networks. Let's learn how the brain works. This is a great example of biomimicry, right at the bottom one. It's slime mold. It's a one-cell organism. What they did is, this is a map of Japan with all their stations. They put the slime mold in the middle, and within 24 hours, it mapped the optimized route between all those parts. What they did is they just put food for the organism as stations, and the organism within 26 hours actually found out the optimal route to do their trains. They didn't need an AI algorithm that ran on a Google platform for 2 months. They didn't need that. All they needed was a single-cell organism to do the exact same thing, find the optimized route. Can we learn from this? Can we learn from using, instead of billions of neurons, a single-cell organism to do the same thing? Is there a different way in which we should do our neural networks? Because what we've done is we copied the form, right? We've copied the structure, right? But we haven't copied the process yet. So what's the process? And the keynote this morning was speaking a little bit about that, the process of, actually, it's not just million neurons connected to each other that tries to come up with weights. There's a different process in which the brain does it. And the system consists of different brain parts that talks to each other. The speaker this morning was talking about replay. So this brain part does a replay for the other one. That's the system. So we shouldn't just copy the form, copy the process in which it works, copy the system in which it works as well. And then ultimately, and this is my last slide, and I will end off, it's all about the value lies in integration. Understand the business problem that you want to address, or the problem in nature, or the problem in human society that you want to address. Create different perspectives of looking at it. So if the business problem is in the middle, you can use machine learning. You can throw data at a problem, whether you use unsupervised learning or supervised learning. But ultimately, you can use mathematical modeling as well. So that's what physics does, right? How does the world work? Let's create a mathematical model of it. That model works well with your machine learning as either initial parameterization or as a model against which you want to test. You can use stats modeling because it gives you sort of the trend of the data, the model that's inherent in the data. And if you put all of these three together, you can actually come up with different values. And ultimately, you must link it with the user. And that's where ontologies and the sort of semantic modeling is important, because it gives you a view of the world that you can incorporate with your machine learning, your maths, your stats, and then put it into a usable tool. If it's not into a usable tool, business will not use it. Excel, for us as AI people, might look stupid, but it's usable, and that's why it's so popular. Put your AI algorithms into a usable world. Just don't think because you've put it into a Jupyter notebook or into some MATLAB code that now the world, you're going to change the world. Put it into a usable tool. And then ultimately, we'll be able to see that actually this brings value to the business. And value from three perspectives: from the customer perspective, from the staff perspective, and from the business insight, because that is what business wants. Thank you.
Thanks for a good presentation. Human and AI. We all know about the new object detection model, YOLO. So it has came up with this idea of perfecting self-driving cars. So my question is that if a company implement a car like that, like maybe Mercedes-Benz, and then I go buy that car, and then it get involved in an accident, who gets the blame? The customer, the company, or?
So the first question yesterday was similar. And my answer was I specifically left it out of the presentation because it's a new research area, right? We must still understand the ethical implications and the moral implications behind AI implementations. We haven't done that. It's still in the research field. And we're making the same mistake we made with the technology world, which means regulation follow technology, right? Somebody implements it first, and then somebody steals Facebook data, and only now we want to implement privacy laws. We know AI is coming. We know technology is coming. We know self-driving cars is coming. Think about it now. Think about the regulations now. Think about the ethical implications. Think about the moral implications. So I can't answer the question. We as a community must go and research it and say, this is the answer as to who owns the decision that an AI machine makes.
Do we see maybe some developments whereby you have now business strategies being developed end-to-end by AI? Because a lot of strategy development is around, humans have this inherent foresight, common sense, or have a feel of what they think is coming. But you have your AI that uses a completely data-driven approach. We have seen it succeed when it comes to the era of, chess playing, areas of playing games. So do we see developments whereby AI sets your strategy?
Okay. We don't see it yet, and that's for two reasons. One is the mistrust that humans have, right? It took us a long while to trust using Excel and the outputs that come. It took us a long while to trust Google search results, right? It's going to take us a while to trust AI. We've had examples where we've gone to people in charge and say, this is the right way according to the data that you must go, and then they go another way. Because people sort of still, I believe in myself, man. I make the decision. And they don't understand that intuition is actually just us subconsciously analyzing all the data that we have available. So if the AI can give me more information, more data, my subconscious, my intuition becomes better. So the number one reason why that hasn't happened is because of mistrust of humans, or humans coming to the ability to do AI adoption. That's why when I made this presentation to business yesterday, I had a different slide. And the number one thing was invest in your people, do AI adoption. Meaning, you don't need to hire data scientists, that's not the point, but make all of your employees used to the ability to use AI, right? So the people in here will create something that says, press this button and I'll do machine learning on your data to understand churn, to understand which customers will leave you. So make that person comfortable to pressing that button and make them understand the outputs from it. Oh, so this machine is telling me this, so I can make this decision. We must still teach our employees to do that. So that's a very important thing, the AI adoption. Number two, and this is for the AI world, is to model a business so that you can make a strategic engine is not easy. Because you're not just modeling data. You have to model the policies of the business, you have to model the different employees, you have to model the connections between them, you have to model the actions that the different parts of the business does. And that's not an easy thing. And that's one of the things that I think research must focus on, because that will turn business around like that. Because once you've modeled it, you can put it into this reinforcement learning, gaming engine, and it can run for you. But nobody has done the modeling, because it's not easy. Semantic modeling isn't easy, concept modeling isn't easy. It's not just about analyzing data.